now we'll have our last testimonial. It's David García Álvarez from the Complutense University, and he's gonna tell us about his study, changing urban areas with Copernicus land datasets. David, whenever you want, the floor is yours.
Thank you, Andrea. Okay, I'm David García Álvarez, and I'm gonna make today a short presentation about how to monitor land use change in urban areas, making use of the Copernicus land products. Let's see if I can. Yeah, there we go. First, I would like to introduce myself. I'm an assistant professor at the Complutense University of Madrid, and my research until the moment has mainly focused on the analysis of urban and rural dynamics, making use of land use and land cover data, and also on the modeling of these dynamics, making use of pattern-based models, which are fed or used as input data, this sort of land use and land cover data sets. One of the most important results of the research that I have done until the moment is this open access book that you can see displayed on the screen, which provides you a general review of all available global and continental, also for Europe, land use cover and data sets worldwide. You can find details on how to access to them, which are their characteristics, etc. Also, the book provides you with a few practical exercises to validate and analyze the information that these land use and cover data sets provide, and which will be something similar to the thing that we will be doing here in this very short presentation. Well, when we want to monitor land use change in urban areas, we will usually come with a first and important question, which is how do we do this, or which data do we need to do this? To answer this question, we have two potential answers or two potential options. The first one would be like to do our own developed data sets, to create our own data sets. In that case, we would have the advantage that those data sets would be fit for our purpose, but however, you have a main disadvantage, which is the quantity of time and resources that these require. On the other hand, we can make use of a viable standard data sets that are useful for many different purposes and are created by initiatives or institutions like Copernicus. The main advantage of these data sets is that they are already validated, and also they have been already tested by different users. So this experience of other users can provide us with a lot of information on how to use these data sets. Also, because they usually cover large areas, they allow for comparability. In the case of Europe or for European urban areas, the most relevant land use covered products that we have currently available are the ones that are produced in the context of the land monitoring service of Copernicus, which are also available in WEkEO, so you can download them through WEkEO, or also you can try to analyze and make computation things in this cloud platform of WEkEO. Today here, I'm going to focus on three main of these datasets that I think they are the most useful to make the analysis of land change in urban areas, which are the core inland cover, the urban atlas, and also the high resolution layer of imperviousness. However, there are many other products available, which you can see displayed in the screen as well, although they usually provide less thematic detail and also they are usually less accurate. You can get information about all them in the link that is provided here in the presentation, which you will have available at the end of the webinar. Trying to go through each of these three datasets that I've previously mentioned and trying to see which information they provide, I'm going to focus first in the current land cover, which we could say that is the most famous land use and land cover dataset today available in Europe. It's a dataset that allows us to differentiate between different categories of land use and land cover. Like, for example, it allows us to say where there is a residential area, an industrial area, an urban park, etc. It's especially convenient or good because of its spatial and temporal coverage. This means that it covers most of the European Union and most of the European territory, and it covers since 1990. In this way, we can use scoring to study any relevant European settlement or urban area since that date onwards. However, the main disadvantage of current land cover is its coarse thematic and spatial detail. In this way, when we use or analyze urban dynamics with current land cover, we can get a general perspective, or we can get an understanding of the general trends in terms of urban dynamics in Europe, but we cannot really focus on the details. For this, we would need to use the urban atlas, which is quite similar to Korean. It also differentiates between different land use or land cover categories, what is industrial, what is residential, what is an urban park, etc. And also it gives us some information about land use intensity. In this regard, it differentiates, or it has several categories that allow us to differentiate between different grades of urban fabric density. In terms of spatial detail, it's 10 times more detailed than Korean land cover and also provides more thematic detail. It differentiates among 17 different artificial categories, whereas Korean land cover only differentiated among 11 artificial categories. However, the main disadvantage of the urban atlas is that it's only viable for the European functional urban areas. So if you want to monitor any urban dynamic in any area that is not inside a functional urban area, you should use another dataset. The final dataset that I will be using or commenting and presenting here today is the high resolution layer of imperviousness. This is a layer that informs us or provides us information on which is the degree of sealing or imperviousness of the European territory. In this way, it informs us about land cover and how the intensity of the land cover changes with the years. However, it's different from Korean, and it provides different or complementary information to Korean than the urban atlas because it does not focus on land in use and it does not provide information on the land in use. However, it's very detailed, its spatial resolution is very high, and it's also more frequently updated every 3 years with respect to the 6 years of Korean and the urban atlas. In the 3 cases, the Korean, urban atlas, and also in the high resolution layers, you have layers of changes which are viable to study or monitor land change. This is quite important because if we want to study land change, we should use these layers of changes because they are treated to avoid for any technical error, any uncertainty, and also they provide more detail when studying land change. So we should use these layers of changes, but know the status layers, comparing them for the different years. All in all, what we have here, there are 3 different products that allow us to comprehensively understand urban dynamics by providing complementary information at 3 scales of analysis, from the coarser one of Korean land cover to the finer one of the urban atlas and the high resolution layers, with the higher resolution layers providing complementary information to the other 2. We can use these 2 products also, and this is quite interesting, something that I've been working with in the last years to make validation exercises or to do this sort of fine scale profile analysis of other land use datasets. For example, I can assess the quality or the uncertainty of the Korean land cover dataset by comparing it or trying to make an analysis with the information provided by the higher resolution layer of imperviousness. And I could do or I could use any of the other 3 datasets to, for example, validate or understand which is the information contained in any national renal product or even in datasets that are created by yourself. Now, I'm trying to connect with what you will be seeing tomorrow. I will explain you through a practical exercise how you can get access to these products and also how you can analyze these 3 products for the case of the studying the urban dynamics of Madrid. To this end, I'm going to share my screen. Okay. And I'm gonna, although you will see this more in detail tomorrow, I'm gonna explain you how you can get access to the WEkEO data viewer to this data. To this end, you get to the WEkEO data viewer, then you press in this plus button, and you can look for the, for example, Korean land cover dataset. You add it to the map. You can see it on here. So you can see the information that it provides, also the legend, and here you can download it. As I told you before, it's quite important that if you study land change, you work with the layer of changes. In this case, the Korean land cover change layer for the period from 2012 to 2018. And you choose the, for example, year package format, you request the data, and you move to the jobs tab, and you can find here the file that you can download. Because we don't have a lot of time, I've already downloaded the information for the other datasets. What we download from with the WEkEO service is a zip file. So the first step would be to unzip these files. Once you unzip those files, you can upload them or you can load them in QGIS, for example. And here I have all the information that I've just downloaded. In the urban atlas, you have you have a layer with the boundary, or in this case, the Madrid functional urban area, and also you have the layer with with the changes provided by the urban atlas. You also have a layer with the changes that the core inline cover provides, and also we have a raster file for the changes of the high resolution layers. As you can see, I have already the 3 layers clipped or with information only available for the case of Madrid, because I've downloaded these layers and I've already clipped them, and also in the case of the high resolution layers, because they provide a different layers for every 3 years, whereas the core inline cover and the urban atlas is available for every 6 years. What I did was to combine the 2 layers that I've downloaded in just one with the raster calculator. We don't have time here to go through all these steps, but in the materials that you will have available at the end of this webinar, in the presentation that I did, you will find a lot of slides with all the steps that you could follow to do this clipping exercise, to download the other 2 products, and also to make this combination or union of the 2 raster layers. Well, the next steps, once we have the layers that we can use to study land change, would be to really understand what they mean or how are located in the space those changes. To this end, we need to symbolize those layers, and to symbolize the layers, we can make use of the information or the symbolization layers that are already provided by Copernicus when downloading these products. For example, for the case of the urban atlas, if we go to the properties of the layer and we go to the symbolic tab, I can try to load the style that is provided by Copernicus. So here it's, well, in the folder that we download, there is another folder that is called legend. And in the legend folder, there is a file that allows us to symbolize all changes, as you can see here. So now, since I've symbolized the changes, I can really see that, for example, in this case, what I have is a new green urban area that there was not before there in 2012, and it's now in 2018. I should follow the same steps to symbolize the core inline cover layer, but in the case of the high resolution layer, because it's a raster file, I need to do a different procedure. I go to the assembly tab, I need to choose the render type, which is the palette unique values, and then here in this icon, I load the color map. I will look for mine, which I have here. Sorry. And you can see here the information that this layer provides you. In green, you have displayed those areas that they do not change at all in the period of analysis, whereas from yellow colors to red colors, you find in different degrees or percent displayed those areas that have a higher degree of imperviousness regarding what was the status in 2012. The next step is, once we have the symbolization in what we can create our own maps, etc., would be to get a summary of the statistics of the main changes that happen in our study area. To this end, we can make use of 2 main tools, which are, in the case of QGIS, for the raster layer of the high resolution layers, the raster layer zonal statistics. Okay, I open this tool, the raster layer zonal statistics. In the input layer, I choose the high resolution layer. In the source layer, I choose the same, so it's quite easy. I could save the result. When I run it, I could obtain a table from which, if I order the values of the first column, I get a list of the values of the raster. Minus 100 would be that there is a decrease of 100% in the degree of imperviousness. 0 would mean that there is not change, and for example, 50 or 50% would mean that there is a change of or an increase in the degree of imperviousness of 50%. Then in this table, we have another column, in the second column, the M2 square, which reflects us in or show us in square meters, which is the area affected by this change. And in the count is the third column that is interesting for us, that provides us an information of the number of pixels affected by this change. We can export this table to our Excel, and that way we could really work, understand and analyze and try to create graphics of all that change according to the high resolution layers. Then the other tool that we can use to summarize the changes and get this statistical summary of changes in core inland cover in the urban atlas would be the aggregate tool in QGIS. Because it takes a bit of time to fill this tool, I already have it here prepared. So for example, for the core inland cover, we have to decide which is the field that we use to make the summary or the aggregation of the data. In this case would be this change field that summarizes summarizes for the core inland cover, which are the main transitions that happen. Like for example, transition from urban fabric to industrial area. Another transition will be from construction sites to urban fabric, etc., etc. And then I design here the table that I want to create that tell me which is the transition, which is the code of each transition and description of each category involved, and then the most important data here, the number of polygons that are involved in each transition and also the area involved. I could save the result here. I'm gonna run it, and what I get is a new file that if I open then attribute table, it gives me an idea of all or a summary of all changes that have happened in my study area according to this data. For example, the most relevant change for the case of Madrid in the period that I've analyzed is the change from construction seats to the discontinuous urban fabric. If we repeat the same process for the urban atlas and we, as I said before, export the three tables to Excel and work with them, we could get something like this. That allows us to, as I said before, make an analysis at three different scales and level of details of the urban dynamics in Madrid, getting a general overview and a contrasting also perspective of which have been the changes that have happened in our urban area or in general in the urban areas of Europe. We don't have time here, but then we could use all this information to compare the data sets, see if there is any error in one of them, etc., etc., etc. So this is all on my side.
Thank you, David. Thank you very much also for the short demonstration at the end. And we already have certainly a few questions for you. So the first one, I don't know if you have any information on this, but since you have been working with Corinne, maybe you would have last update on Corinne's land product was in 2018. Are you combining any more fresh data for more accuracy to time now?
I'm not sure about the question, but it's true that in the last update, well, in the new update or new way of producing Corinne from 2018 onwards, they are created a new structure of Corinne in which they are combining many different data sources that are available in Europe from different institutions and also from open data sources to create a sort of data box where you can get a very detailed perspective of which are the land use and covers in Europe, and from that information they will be creating a new foreign in the future. I'm not sure if that's what the that is asking.
The question, yeah, me neither. Also, in terms of the updates, would you know if there's something planned to update this product? On my side, I don't have any vision on if the product will be released more recent time or not, but
No, actually, it's a nice question because, yeah, the last data available is 2018. We are already in 2024, and Corinne is usually updated every 6 years. Every 6 years, the information that I have is that this year they are producing this version, so it will become available soon.
Oh, perfect. It's very good, actually. There was a few questions related to that, actually. There was a question about the geographical resolution. So are there data available for Africa as well? And is it, oh, maybe that's more general question, or I don't know. Well, if it is a
Yeah.
general question.
Yeah, actually, I mean, at the beginning of my presentation, I show you this open access book, and in that open access book, you have a review of all available data for global scales and also for continental scales. In case of Africa, there is not really, at least there I know, any specific land use data set like the one that we can find in Europe, just mapping Africa in detail for urban covers. But however, there are many global data sets that give you information about urban covers without thematic detail. They usually only provide a difference between what is urban, what is not urban, and also maybe the degree of siltiness of the soil. But yeah, you can use those to study African dynamics.
Exactly. And yeah, like we mentioned throughout the webinar, of course, it is Copernicus is a European program, so we do tend to focus more on European region, although we do also include global data, but maybe with a little bit less resolution and with less detail, yeah, as you said. So update again, we answer to that. Fortunately, it's going to be updated soon. And about coding a land product again, change layer only shows on land use. How do we know what change is?
Well, that was in terms of display. When we displayed, we used the last cover or the land use that was, I mean, what we are seeing is the change, no? So we are seeing the use that is in that case, or in the case that I presented, it was available for 2018. However, if you go to the attribute table of the data, you will find information about which was the old use and which is the new use. And then you can try to make your own analysis, and also you can try to make your own cartographic display with the information that you want.
Okay. Another question, for land use dynamics in rural areas, which dataset would you recommend to complement Corinne?
Well, this is a nice question. It depends on the rural area that you are working, because, for example, as part of Corinne, you have also all their land use datasets available, like the one that focuses in the Nature 2000 areas, and also you have one for the riparian zones, etc. If the rural area that you want to analyze it's not covered by any of these products, you should refer to Corinne, and also maybe you can use the high resolution layers, and also you can try to create your own map based on Sentinel data. And well, this would require time and resources, but yeah, there is not something specific at the European level focusing on all the European territory. But it's important to know at this point, and I would like to also remark that the new version of Corinne that I explained before, it will be quite more detailed. So it will provide data set with like this box data set, yeah, complementing many different sources of information that you can then use to create your own map.
Okay, that could already solve that issue. So have you used both Sentinel-1 and Sentinel-2 data by incorporating each data for the classification?
Well, I've mostly worked with Copernicus data that have been already produced by the European Environmental Agency or the other people. So I have only used Sentinel data to produce very simple maps and not specifically for urban areas. So yeah, I think that you can use it to improve the classification. But definitely this the Copernicus products, this Urban Atlas, the Greenland cover, etc. I would say there are products that have been produced, investing a lot of time, resources with a lot of experts. So it's quite difficult if you don't really have a lot of knowledge, expertise, and also resources to get something similar just by classifying remote sensing in my area.
Another question. How was the imbalance related to land use and land use change classes handled in this project?
Well, my main work and where I mainly research until the moment has been to work with different data sets to see which complementary information they provide. So in this case, having a different number of classes or this imbalance in the number of classes is something that we already take for granted because we already know that we are working at different scales and our purpose is to understand from different data sources the different information that those data sources provide. So we know that we have some data sets like the urban atlas that provide us a lot of detail and thematic detail, and the other one no. But it's something that we already recognize and allow us to provide these complementary perspectives.
There's someone asking if the codes that you use, if you used any coding programming, if they are available, or if that's open, or if it's your part of your
Yeah, if you
research,
refer
or
to any code programming, I didn't use any code programming. Where
Okay.
everything that I did here, which was like something very quick, it has been done with QGIS, and in the materials that you will find available at the end of the presentation, you will have all the screenshots and all the steps detailed, so you can follow very easily all the steps.
Oh, that's great. So you would be able to maybe read to a small
Yeah.
exercise like the one you showed. That's great. Thanks a lot. And again, I don't know if you would know this one, but are there any initiatives to further detail the vegetation types on the land use maps of Corinne land cover?
I would say that yes, part of the new Korean there will be like much more information that will allow to characterize each land use and land cover in detail. For the specific information of the vegetation types, I'm not sure, but I'm sure that there are and I know there are other land use products that specifically focus on vegetation. They are available in raster data, so you can combine the information provided with Korean with the information provided by these other products, and you can get more detailed information of what each land using or land cover in terms of vegetation means in Korean.
Mm-hmm. And one last one.
Okay.
What about your uncertainty for land cover class? Do you use dynamic world? Dynamic world. I don't know what it is, but maybe you do.
Yeah, it's
Which
another
provide a
land use dataset, land cover
okay
dataset.
dynamic world which provide a probability for each land use class.
Well, the approach that I usually follow to assess the uncertainty of any land use or land cover dataset, it's usually like I work with dataset that have been already created to do this cross-scale comparison. So I have some dataset, and we, especially in Europe, have many different land use and land cover datasets. So we use the most detailed ones to assess the information that is provided by the Corsair ones. But of course, if you do or your team your own land cover dataset through remote sensing, and you do your own making these probability products, it's quite interesting because it provides you some sort of information about the accuracy of each class.
I can imagine. Okay, now it's the last one. Thank you all, everyone, for all your questions. It's really nice. What about the update of HRL?
I'm not sure, but I would say that it should come also this year, around this year. If you go to the Copernicus website, you should find the information of the last updates of these products. I think, and that most of them they have been already produced, but they are like making the final checks and validation exercises before they become available.
Okay. Thank you. Thank you very much,
Thank you.
David, for your presentation as well. It was very nice. Thank you, all of you three, Francesco, David, and David, for your presentations. That was really nice. Just before we leave, I would just like to remind you that all materials and the presentations of our guests today, they will be made available to you, so you will be able to have more information on their research, their work. And just to give you some information for tomorrow's session, tomorrow we have a practical session. You will see a brief demonstration of the WEkEO viewer. So you will see how you can visualize the data available in WEkEO. You will then see two examples on how to use the data, both using Jupyter programming language through Jupyter notebooks, and using the QGIS software as well. And Now I will just show you a little bit of the platform that you have been following. If you are following online, you had to register, and you have seen the website. You'll see that at the top. Sorry, I'm not sharing my screen yet. There you go. So you will see that at the top bar, you will have different tabs where you can access the agenda, for example, of the event, more about the speakers, but also you will be able to access two tabs dedicated to the practical session, one to the Jupyter notebooks and another one for the QGIS session. Here you will have the guidelines that you can follow to be able to, for example, download QGIS, and then also download the practical tutorial that we will talk a little bit about tomorrow. So feel free to explore these two tabs, and tomorrow bring your questions. We'll have our experts ready to answer your questions. And once again, thank you very much to you all, and have a rest of a good day, everyone. Bye bye.